now we're going to graph the reciprocal functions of cosecant, secant, and cotangent. So one thing's helpful when we graph these is to remember that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So we're going to kind of use that to our benefit to graph these functions. They're still periodic. In fact, cosecant and secant have the same periods as sine and cosine, and cotangent has the same period as tangent. It's just that because we're talking a reciprocal function, they're going to look a little bit different. Okay, so let's first talk about the cosecant function. All right, and here's the equation kind of hiding right here that I'm going to be talking about. All right, so the period is still going to be 2 pi over b, or the absolute value b. All right, but instead of talking about where the x-intercepts are, all right, instead of talking about where the x-intercepts are, because we're talking reciprocal, instead of being at 0, now we're having asymptote because it's not defined there. So reciprocal of 0 is undefined. So now we're going to talk about asymptotes at multiples of pi over b. All right, and then we'll talk about the vertex of the curves in a second. I actually want to graph this guy and kind of talk about what I mean by the vertex of the curves. All right, so let's graph this guy out. All right, and we're going to do a positive period and a negative one. All right, the period is still going to be 2 pi, all right, for the parent function. So we're going to go 2 pi, we're going to go halvesies, and halvesies again. Whoops, this should be pi halves. 3 pi halves, and now let's do the negative version. Okay, so what I'm going to do real quick, and oh, our amplitude is 1, so A is still amplitude, so let's put that out there. All right, but we're going to use it in a different way. Actually, we don't have A for amplitude. That's where the vertex of the curves come in. So let me show you. So I'm going to graph the sine function kind of dotted underneath here, and then we're going to use that to graph the cosecant function. All right, so with sine, we start at 0. Actually, I'm going to put this in black. And we go up to 1, down, down, and up. I'm just going to do a dotted line of this function and talk about the reciprocal. Okay, so if you see that, it's like a dotted version of sine, and we're going to talk about the reciprocal. So now we're in red, I'm going to graph the cosecant. So let's put a dot here in black. So this is the sine of x, or y equals sine of x, whatever. All right, so wherever there's a 0 now, we're going to have an asymptote. Okay, because the reciprocal of 0 is undefined. All right? And then let's talk about the graph. So if we think about it, if we're talking about this is a sine, we have a sine curve here, and we want the reciprocal, we literally flip the curve. So at 1, it would be the same, and then we flip it over. At 1, or negative 1, sorry, that was negative 1. Here at 1, or negative 1 again. All right. So the asymptote towards that 0. All right, so this is the cosecant graph. All right, and they go, I put little arrows on here because they go on forever. All right, so if you notice, sine and cosecant, because the reciprocal of 1 is 1 and the reciprocal of negative 1 is negative 1, they share those points with the sine function. But after that, it flips because we're talking about reciprocals. So as the sine gets closer to 0, cosecant is going to get further away from 0 because they're reciprocals of one another. So the vertex of the curves are now where the old amplitude was, and it's at the halves. So pi, so half of a, whoops. All right. So instead of amplitude, we're going to talk about the vertexes. Okay, so that will be the vertex of my curves. All right, negative a. So she'll talk about, it's not really an amplitude anymore, it's where the vertexes will be. And they always occur at that fourth way, or about a fourth way through the period. So now we're going to talk about the secant, and secant is the reciprocal of cosine, right? So the period's going to be the same. It's still going to be 2 pi over b. But now we're going to have asymptotes where cosine was 0, which is multiples of pi over 2b. All right, so let's graph this. We're going to graph the cosine one. And a dotted line again, up to 1, down to 1. Period of 2 pi. Halvesies. Halvesies again. All right, and then we'll have the negative version. 2 pi, pi, 3 pi halves, negative pi halves. All right, so I'm going to draw the cosine one. So remember with cosine, we actually started at the 1 and then went down to the 0. So cosine looked like that W shape. Okay? All right, so this is cosine. And now we're going to do the reciprocal. So again, we're going to flip. So first of all, where there's zeros, that's where the asymptotes are. Notice that's multiples of pi over 2. And then we're going to flip here, flip down here, flip there. I guess we'll have part of a guy here. Put arrows on this guy. And notice they look like little parabolas. In fact, that's what they are. They're like little quadratic parabolas. And we'll have a half a guy here. All right. So that's what secant looks like. And now their vertexes are at 0, a, pi over b, negative a, 2 pi over b, a. So wherever we reach the, of the top and bottom of the wave for cosine, is now we have a vertex for the secant. All right, the final reciprocal graph we're going to talk about is the cotangent. All right. So cotangent still has a period of pi over b like tangent. But now we're going to have asymptotes where the tangent had zeros, is where cotangent is going to have asymptotes. So that's multiples of pi b. And now x-intercepts where the tangent had asymptotes. So that's going to be pi over 2b. Right? And then, but the halfway point will still be A as the y coordinate. So that's the same at the halfway point. All right, so we're switching asymptotes and x-intercepts. So whatever tangent was an x-intercept, cotangent is an asymptote, and wherever tangent was an asymptote, cotangent is an x-intercept. So let's graph that puppy. We'll go to 2 pi. All right, so pi, 2 pi. I know a period is just pi though. Negative pi, negative 2 pi, halvesies, halvesies. Oops. All right, so let's draw on our asymptotes. So we'll have one at 0. We'll have one at pi. We have one at 2 pi. And then over here. All right, now our x-intercepts are where tangents, asymptotes were. And instead of swishing up, we're going to swish down. Oops, let's add a 1 at the halfway point. All right. And we start here, and we swish down. All right. Here, here, and we swish. Here, here, and we swish. So again, where cotangent was up, tangent will be down. And where tangent was up, cotangent will be down. Because they're reciprocals of one another. Okay, so now we're going to do some examples. We're going to shrink and dilate and expand, but we're not going to do any shifts with this. All right. So we'll pick new periods and new asymptotes, but that's about it. All right. So the period of this guy is going to be pi over b, which is pi halves. Okay, we'll draw 2 periods. All right. Our asymptotes are going to be multiples of pi over b. So at pi halves, and in this case, negative pi halves. And our x-intercepts will be at pi over 2 times b, which is 2 times 2, which is at the pi fourths, and negative pi fourths. All right, so let's graph that. We're going to graph just 2 periods. We're going to go out to pi halves, out to negative pi halves. This is negative pi fourths, pi fourths. We'll give a little halfway points for the A, which is at 4. Okay. We'll draw our asymptotes here and here. Oh, we got to draw one at 0 too. Okay. And then our x-intercepts will be at fourths, negative pi fourths, and we'll go up to 4, down to 4, and draw a swish. Up to 4, down to negative 4, so down to 4. And we'll draw our swish. Pretty straightforward. So as long as you pick the period and your asymptotes and your x-intercepts correctly, graphing it isn't too bad. Our next example is going to be a cosecant, which again is our reciprocal of sine. Okay, so let's see, our period is going to be 2 pi over b, which is 2 pi over 2, which is just pi. And our vertex is going to be where y is 3 and y is -3. All right, and now let's use that information to graph a positive and a negative period. All right, we're going to go out to pi, halvesies again. All right, so just like we picked for sine, -3 pi fourths, negative pi halves, negative pi fourths. All right, so sine started at 0, so we will start with an asymptote at 0. And then we went back to 0 here, so that's where our asymptotes will be. All right, and let's see, we're going to go up to 3 and -3. 1, 2, 3, 1, 2, 3. All right, start up here, graph, down here, graph, another one down here, and one up here. Okay, so there's my cosecant. So again, I started with an asymptote at 0 because sine starts at 0. So we have to do the reciprocal of that, which is an asymptote. Okay, and then sine went up, so my first vertex was up, and then I went from there. Okay, so again, picking the period, making sure you have the right vertex. After that, it should be pretty straightforward. All right, one more example. Our final example is secant. Okay. All right, so our period is going to be at 2 pi over b, which is 2 pi over 1/8, which is 16 pi. Golly. And our vertex is at a, so it's going to be at 1, -1. So our y is 1, y equals -1. All right, so let's draw a positive and a negative period. We're going to go out to 16 halvesies, and then half of that is 4, so this will be at 12. Okay, cosine starts up, so we're going to start up as well, but our asymptote is going to be at 0. Let me draw the asymptotes in. So we'll have an asymptote here, 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 here. All right, we're going to go up to 1, down to 1, -1, and up and down, and then just, I guess, a part of 1. You can draw the other part if you want to. Oh, that should be right at 16 now. All right, and then the up part of that, 16, and down here at -8. Okay, so when you're graphing the reciprocal functions, think of the original function sine, cosine, and tangent, and do the reciprocal. It'll help you out. So again, flipping the graphs, asymptotes were the other ones were defined at 0. But again, I think that's all I want to say. That's good. Let me know if you have any more questions.